Hello, thank you everyone. I'd like to welcome you to the November SURF webinar series. Today we have Dr. James Henderson from Corteva speaking on resiliency and sustainable remediation. Time is up, looking at this from a global perspective and how a project lifecycle occurs. Next slide, please, James. So for those that most of you probably are aware of SURF, we're the Sustainable Remediation Forum, but for those that are not, we envision a world that is healthy, resilient, and improved by remediating degraded environmental conditions through sustainable practices. And so we are advancing the science, we're developing best practices, we're holding webinars such as this. We also have technical initiatives, different outreach, and just sharing the knowledge, which all of us are passionate about, is sustainable remediation. I encourage you to check out our website, sustainableremediation.org. Check out some of our other webinars on our YouTube channel. And with that, I will introduce our speaker. First, he's supported by Dr. Linlin New, who's an environmental engineering consultant who works with ERM in Raleigh, North Carolina. She obtained her PhD in environmental engineering and earth sciences from Clemson University in 2019. Dr. Mu's academic research focused on nanoparticle fate and toxicity in soil water plant systems, and provider experience in experimental design, data processing, statistical analysis. In addition, she has expertise in groundwater modeling, subsurface remediation, data management, and visualization. And our speaker, Dr. James Henderson, is an environmental scientist by training and has several degrees throughout the doctoral level. He spent most of his life living and working in Latin America. He considers himself an environmentalist and is responsible for remediation at Corteva Agri-Sciences sites, the agricultural spinoff of Dow DuPont. James worked with teams from Mexico to Argentina to oversee remediation of soil, sediments, water, and groundwater. They implement diverse techniques in doing this with a focus on natural and sustainable technologies. And another plug for Corteva, they are a gold sponsor for SURF, and appreciate your expertise, James, and looking forward to this presentation.
Thanks so much, everyone. It's an honor and a privilege to be here. Lin and I appreciate the opportunity. We'd like to thank team members that you see across the bottom here. Lots of folks contributed to the ideas, the slides that you're going to see, and gave us feedback. So Paola, Cesar, Jaime, Renata, Kevin, Hannah, Felipe, Alini, Mariana, Maria Cristina, John, Pui, if you're out there, thank you very much. We appreciate your help. So everyone, we're not going to start yet because we're going to ask you a question. And Amy is on the line. You should see a poll question pop up. I've never done this before, but hopefully, Amy, you see some responses coming up. It should be fairly easy for you in the audience to click one of the boxes.
I do. We'll give it just another couple seconds and then I'll close the poll out.
And something else to mention that I forgot to is if you have any questions during this presentation, please put them in the chat function, and then we can address them at the end or during the presentation.
All right, James, I'm gonna close the poll out and I'll go ahead and share it with the audience.
Okay, thanks everyone. This is interesting to me. You'll get 3 more poll questions. Really appreciate you answering this first one. The reason we ask is because whether you know it or not, we're all children of the Bruntland Report. The Bruntland Report was written by a commission of the United Nations in the 80s, published in 1987. And it coined the definition of sustainability that we all use today. It's the most widely accepted definition. It's not the only one, and there were others before it, but it's the one that we in a variety of technical disciplines use today. In addition to that, it proposed the 3 pillars of sustainability. This had also been talked about by others before the Bruntland Commission, but they put it in a way that it was so easy to understand how to begin to apply sustainability and make improvements in the world today, opposite global change, climate change, poverty, environmental degradation, and those three pillars have been used ever since. But we decided that we would reread the Bruntland Report. It's been 20 years since I read the document. And what we've forgotten is the urgency of the Bruntland Report. This document on every single page, and it's got hundreds of pages, sounds a tone of alarm about climate change and environmental degradation around the globe. And you can see just one of the many sentences and paragraphs here where the authors are saying in strident, urgent terms, do this now, be sustainable now, be resilient, rectify environmental contamination, address climate change. So we started thinking about this urgency. And these are some reflections in time for us. There's a phrase in the Bruntland Report right up front that became very famous and was mentioned many times in the 92 Rio conference, the first COP conference. COP 26 is going on now. 5,000 days. 5,000 days, the authors wanted to see measurable, meaningful action opposite global climate change and environmental degradation. 5,000 days from the publication date was the turn of the millennium, 2000, January 1, 2000. Well, almost 13,000 or over 12,000 days have passed since then, and the pace of climate change has increased exponentially since then. We all know that governments have been slow to respond. Perhaps we in the remediation industry have as well. That's a central point that we're going to make later in this presentation. We evaluated some studies on the passage of time, and it's clear to us that the more time goes by, the less you're able to perceive it. Is that why over 12,000 days have passed and we don't have measurable progress? We don't know, but it's a known fact. And we see this quote, this just came from COP 26. Humanity has long since run down the clock on climate change. The general definition of resiliency mentions that we have to have the capacity to recover quickly from difficulties. The open question is, have we done that? I'm grateful to people like Kevin Morris, who have been sounding the alarm for years about climate change and the need for resiliency. These slides came from a great presentation that Kevin did last week at the SUSTREM conference. For time limitations, I can't read you every word, but this is being thought of in sustainable remediation circles. It's recognized as a need that we improve not just our ability to deal sustainably with land contamination, water contamination, but adapt to climate change, do that quickly and in resilient fashion so we're not vulnerable as climate change continues to accelerate. Here's a great graph. I really like this graph. You see the definitions of adaptation and resilience, and Kevin's the expert on this. I appreciate him letting us use these slides. He's also a team member on this project that we're going to be presenting to you. This graph shows you on a simple XY axis how we need to develop. At the bottom, the origin, we're resistant. We're dealing in a fairly tactical fashion with these changes, opposite climate change and how we do our work remediating contaminated lands. Where we want to be is top right. We want to be transitioning and we want to be changing our processes so that we can adapt going forward. So we thought, before we consider how we want to be more resilient and we choose a project and we test new approaches, how have we been in the past? How long has it taken us to remediate our sites historically? So we have, I believe, Amy, another poll question here, and I'm going to pause.
All right, I think I'll go ahead and we have a majority that have voted. I'll go ahead and close it out and then we'll share the results.
Okay, so we got a lot of yeses. I'm curious about the maybes and the no. The no's, I want to try my best to convince you that that might be the wrong answer. And maybe we can come back to you at the end of this presentation. So before we get started reminiscing about this site in Rio de Janeiro state, everyone, a huge thanks to Renata, who went back through the entire archive of this project and resuscitated the history that I'm going to present to you now. So this site is called Baja Mansa. It's old. I think it's over 80 years old now, and it's big. And the outline here in red is about 400 hectares. It's a mountainous terrain, very complex topographically. It started producing explosives, the ravines. This is where we sited our production buildings for explosives because in any explosion, they would contain the blast force of the explosion. Once explosives ceased, we went forward with a number of different production processes, everything from freons to crop protection chemicals. So we're going to talk a little bit about that history. And I want to draw your attention to these bars right here. And hopefully you can see my pointer and a timeline across the bottom. These bars represent the standard remediation process: due diligence, investigation, risk assessment, feasibility study, lab testing, pilot testing, remedial design, remediation, and O&M. And so what Renata did was she tried to assign these different phases along the history of the investigation of this site. And what jumped out at me immediately, and I've been involved from almost the start, as embarrassing as that is to say, that we started in 1994 and we're still going on this site. We'll talk about that in a minute. Notice that this long green bar of investigation from 94 to 99 is uninterrupted. What does that mean? That means that we were performing small mobilizations to the site, installing 510 wells, writing a report, seeing that the report didn't answer our questions, and then going back out at the site to install more wells. And we did that for a long time, 94 to 99. And then we stopped. That's probably some manager saying, you're not answering my questions, this is not working, this is going too slowly. So we restarted in 2002, and I was involved from this point. And so we're going to focus right now on these bars that are from 2003 onward. So what happened? We did some due diligence. That's this green bar here, and we figured out that we might have a problem. And this problem is at top right in the former Freon's production area, which is here. We had high concentrations in soil and groundwater of chloroform and carbon tet. These are precursors to freons that were produced in this small area. Risk assessment work, feasibility study eventually led us to conclude that we needed to install a bioremediation system, a line injection system that would stop the progress of the plumes of these materials towards the river. You can see the river in blue at top right. This is an important river in this state, headed to Rio de Janeiro, and lots of people depend on this river down gradient. So please note this bottom yellow bar here, this is the start of a pilot. So the yellow bar is pilot testing. This is normal for us. We wanted to test out whether this was going to work, and we selected freely available sustainable materials, molasses and milkway. And we carried that forward. So look down here at the left on the bottom. We started this pilot in 2007 and we ran it to 2009. You might be wondering, why would it take 3 years to do a pilot? It certainly wouldn't take this these days. So we had so many problems. As we look back upon this, we start to understand why we have been inefficient. We had to perform technology transfer. This took a number of years. This has never been done before in Brazil. We had a lengthy regulatory approval process. We had to do many meetings. We had to do workshops to explain what bioremediation is about. We had internal disagreements within the company. There were some in the company that wanted to just install a pump and treat system, which wouldn't have worked. So those conversations took, dare I say, years. We had many operational problems. We installed this system wrong, I expect, especially in the pilot phase. We dumped a lot of stimulant, biostimulant on top of the water table. We had blowback that occurred into sumps, into piping runs. The local impacts were significant. You may be asking yourself why there's a lightsaber dancing roach at top right. This is an anecdote, and remediation that occurs over so many years is full of anecdotes. The first time I went to see the pilot operation with a VIP from Brazil, my most important upper management, selling this remedy as the best one that we could do. We wanted to show him this sump. We pulled the cover off the sump, and out flies a locust-like swarm of roaches. Why? Because the sumps were always full of molasses and milk whey. And if you got freely available energy, everybody's going to show up to the party. Just that little incident where people had to scatter and the roaches flying everywhere set us back 3 months. So the local impacts of what we were trying to do were significant, and they too slowed us down. Now, after that, we were able to update our design. We installed these systems of injection wells. We chose molasses in the end, and we were able to arrest the progress of this plume. So in the end, it was a happy story. But by the time we got to that point, from 1994, you can do the math, many years passed. And if you look at the top green bar, we're still investigating this site. We may have significant data gaps still. So this is a long time frame, everyone. This is still amazing to me, having worked on this project for the majority of the life of the project, that I've forgotten all these years have been spent. And you can see the damage here, the past, the future, and I appreciate Felipe Gasparini, who's the project manager of this site at the moment, doing a great job, giving him his best estimate for the future to close this site out and the total. And we've got lots of doubts still, and these totals may not be accurate. But any way you look at this site, it's taken us, or it will take us, at least if not more than 30 years to remediate it. Think about the pace of global climate change. Think about adapting to that. Think about resiliency. Is that resilient? So we have these new projects coming online. We're a newly formed company, and we see the opportunity to explore improvements in this process. We don't want to spend the next 30 years remediating our new sites in Latin America. We can't do that. It's not sustainable, it's not resilient, and climate change won't permit it. So I may have skipped the polling question there, Amy, but I think we can go ahead and jump into this now. Does this jive with what you got from me? Or are we doing the next polling question later? Sorry, Amy, I'm forgetting at the moment.
I had slide 15 was our next poll.
Okay, well, let me keep going with this. I seem to have neglected putting slide numbers on this, so that's part of the problem. Let's give a quick explanation, and then we'll get to the poll question. So thanks, everyone, for your patience. I want to credit Mariana Favero, who's the ERM project manager for this next site that we're going to talk about, also in Brazil, because when we started talking about our new projects, and this one in particular, Mariana, in one of our meetings, and I think this was late last year, said, have you ever heard of Agile? And we started reading up on Agile. It's a software development technique. And it developed years ago when software developers became frustrated with the slow process of their software development. On the left, you see what a traditional software development process is, and this is similar to remediation. It was conducted in sequential linear phases, upfront planning and in-depth documentation. Best for simple, unchanging projects. You complete one phase before you go to the next. Agile is the opposite of that. It's continuous cycles, parallel path, tasking, different teams that are functioning at the same time but collaboratively. It's flexible and it has continuous stakeholder involvement. This is the common view of how Agile works. Lean came up with this view of Agile, which I prefer. This is a Tangram puzzle, 7-piece Chinese puzzle. I tried to do one of these one time, I remember now, very difficult. Waterfall, or the traditional way, could be the puzzle pieces that haven't been assembled. And so this might be each of those work streams that we saw in remediation, each of those projects that we would try to perform now together aren't assembled. People aren't talking to each other. These projects are isolated. The leaders of the projects don't talk to each other, much less collaborative. Easy to set up, but harder to bring to a quick conclusion in a resilient fashion. Whereas when we see the puzzle pieces assembled on the right here, it's clear that it's integrated. Everybody's thinking together. The projects are connected. The project leaders and participants are talking to each other. It's difficult to front-end load it, but in the back end, you save time. So I really like this view of what Agile brings to the table in terms of how we are going to approach this next project that we're going to talk about. So Amy, I think I changed my slides. Is now the next poll question? Sorry.
We can go ahead and launch now if that works for you.
Thanks very much. Appreciate your patience. So everyone, we have an open question about Agile. We just want to gauge your knowledge or lack thereof about Agile before we talk about the next case study.
Okay, I'm going to go ahead and close it, and then I'll share the results with the audience.
Oh, sorry, Amy, I seem to have turned off my audience view. Okay, so we've got quite a few people that have heard of Agile. Some know and some maybe. Okay, everyone, thanks very much. That's very helpful. I appreciate that. So again, what do we have to lose in trying something new? And yes, you guessed it, we're going to try Agile at this site. This is another site in Brazil, in Bahia State in northeastern Brazil. And we're staying with this same portrayal of timeline and remediation tasking. So again, top right or left, sorry, you see the task: investigation, modeling, back diffusion, microcosms, bench testing, pilot testing, remedial design, remediation, O&M. We're doing all of these things in an agile way, or we hope to. What we're showing you against the site, which is this light blue shape, and these points, is a great high resolution characterization that team members have come up with, John Soul and his company. And I'm not here to talk in detail about this investigation. We're going to be focused on how other tasks are going to mesh in an agile way with this investigation. So you see two bars we're going to start with. So we're trying to show you how we think agile will work, but we can't just show you everything at once because it gets very confusing. Remember, we're used to doing things in a waterfall, linear way. This has been hard for us to wrap our minds around. We hope that we can explain to you today how we're planning on doing this. So I want to thank our Agile expert, Cesar. And I think Cesar is on the line. Cesar, if you're out there in Agile universe, I hope that I didn't get any of this wrong, and I hope I didn't mess up your animations. And the reason I'm using Cesar's exact words, everyone, is because now I know just enough to be dangerous. I am not an Agile expert. And one caution that I'd like to make, if you want to start adapting Agile on your projects, and we'll talk about that at the very end of this project, don't think that that's going to be easy. We'll also talk about that last point. But these are Cesar's actual words, and I'm going to read them almost verbatim because he's explained how this is going to work to me in the last 2 days, and now I'm going to explain it to you. So we usually get the data ready to be used at the end of the project, right? And so the end of the investigation project, the green bar upon which Cesar is standing, would be 2022 Q2. And then we pass that along to the project that really needs those data, the microcosms project. That's occurring at the site. We're going to make microcosms to see how we can fix this problem. So that's slow, everyone. That's the old waterfall process. As you can see, the man in the GIF here is walking quite slowly. You would have to do the entire field investigation, write a report, and then send that to the microcosms team. So here's where data has already been generated, and I hope you all can follow this. This is somewhat a confusing animation for me because I'm not used to these concepts. But right in the middle of that lengthy bar of investigation, we have the opportunity to be agile and to sprint. What if we could break the project into smaller pieces to gain access to the data before the end of the project? We can do that. We can divide each project into smaller pieces of time called sprints. With this, we can have access to the necessary information as soon as it is generated. So that's what we do here. We split this investigation project into two. Here we're sprinting. This is a fundamental tenet of Agile. Let's make it a little bit more complicated. It's easy if you're just looking at this as two projects. But what if we have three? And in actuality, we've got 7 as part of this project. How do you know which data are crucial? How do you know if all projects are using the same data? How do you prioritize the data? So we came up with this term called variables pool. I think that term is from Cesar and my co-author, Lin Lin. It may have already existed. But what we mean by that is all the variables being placed together. We're going to try to illustrate that now. At top right, you see variables, inputs and outputs for these 3 project teams: investigation, microcosms, and the pilot. The pilot, we hope to start while the microcosms are being concluded. So we identify all the variables. We understand the flow of information amongst these different teams. And with this, we can prioritize sprints, and we can guarantee that the values of the variables shared are what they need to be. In the past, in the waterfall past of remediation, we would never do this because one team, a field team, would do the field investigation. They would write a report. The next team, the microcosm team, a year later would come in and do microcosms. They might read the report or not. They would generate their own data. Then the pilot team comes in the next year, and so on and so forth. This is inherently inefficient. And what we seek to do here is connect all of them, as you see here. So this is one example. You've got hydraulic conductivity being supplied to the pilot team from the field investigation team. We've got soil type going to both the microcosm team and the field investigation team. And we've got organic carbon measurements. These are just 3 example variables. We'll talk about the entire variable pool in just a few minutes. So here we can see how this single variable touches on 3 different projects. And here we can see how one is fed from the field investigation to one project and subsequently to another. Inputs and outputs are all identified. The flows are clear. Now, I forewarned everyone that that was a bit more simplistic than what we have found, and this never ceases to amaze me. We put together the variables pool, and here's some vital statistics. Let's focus on the left side of the screen first. When we polled all the project leaders of all 7 projects, I thought we were going to end up with 20, 30 variables. Well, the latest number is 197. We have 126 input variables that those 7 teams are requesting, that they say they need. Those 7 teams will generate a total of 71 variables. 57 variables pertain only to one project. Why is that? Hard for me to understand that. If only you need that variable, is it that important to the rest of the project? Why are we spending money, time, and resources on that? I think we know there are probably good reasons, but this jumped out as well. And then 2 project variables, 18, 3 project variables, 7, 5 project variables, or 5 variable projects, sorry, here. The top 3, and I always think in terms of top 3 are here. The variables that touch on the most projects: contaminant concentration, organic carbon, and porosity. I'm not quite sure what to think about this. My first impression is, as remediation professionals, we never understood the complexity of the data and the communications that we have been working through all these years. And Agile is going to force us to deal with that. So switching gears here, we don't have time to talk about the technical strategy at this site, but we're very excited about it. What you see here are suspected secondary source zones. Groundwater flows through these source zones continually. When we have long investigation timeframes, we are allowing groundwater to flow through the secondary sources and become contaminated. At this particular site, my co-author Lin, with a model that she created as part of her postdoc progress, showed us that 370,000 liters per day flows into this site. That's water that we can't stop anymore, that's going to come into contact with the contamination and become sustainable. So we're seeking to perform what we're calling source isolation at this site. And we've talked about this several times over the course of the year at other conferences, and we get a lot of questions about source isolation. Source isolation was invented as a concept by Anki years ago, I think in the late 80s. It was patented for a while. To our knowledge, no one ever tried it for reasons we'll get into in just a few minutes. It's quite sustainable because it allows water to flow around and not through. It maintains a constant head, creating a quiescent, clean island around the source zone. And it has many benefits, as you can see here. We're a little short on time, so I'm not going to read the entire slide to you. So one of those projects, one of those bars that you saw is a pilot test. But before this pilot test, we've got to try to benchtop test source isolation. And that's what you hear, that's what you see here. I'm very grateful to Jaime and Alini and Hui for developing this plan. Not only are we going to try to isolate the sources, which in itself is very sustainable because we save all that water, either now while we're investigating the site or after we install the source isolation, and we're bioremediating inside the source isolation the contamination that's there. But we need to see if it works now, and we also want to try to do this via siphoning. Siphoning is an inherently sustainable technique to move water. It's been done for thousands of years by human beings, but once we got electricity and figured out we could pump water, pumping is a hydraulic hammer for every nail, we forgot about siphoning, or at least most of us did. You can still see it used at industrial plants, and there are other applications for it, but we had never tried it. So what this system is you see here is a benchtop that we've designed. We're actually constructing it now, where we are going to try to, in a 1 meter long tank, 0.5 meter high, create a source isolation here and here by intercepting water with siphon wells, passing the water into a hold-up tank or a kaizen, and then pumping it again to down gradient wells, thereby passing this secondary source. We're really excited about this because we have some initial test results. I'm circling this. We don't have time to run this video for you. This is just a simple fish tank with 2 soil types, I believe, and a bunch of tubing. There's some tubing in the middle. This is tubing connected to siphon wells. They're made of glass. We have a supply line here. It's feeding into the system. Siphon wells are pulling water up. This water has died. Once we gave this water a little push, it goes and goes and goes, everyone. No inputs of energy. It's the miracle of negative pressure and gravity, what thousands of years ago humans knew about nature and how to use nature to effectively move water. So our technical director from ERM, you see him here, Kevin Morris, has kindly agreed to present the results of this very interesting evaluation later this year or next year, maybe at SUSTREM, which this group is hosting. We're excited to be able to present the results of this test to you. I think it's going to work out great. We're going to conclude this case study with a very practical consideration. How do you keep track of everything? Because if it's hard for us to run a remediation project in the old waterfall method, imagine when we put all of these people together, these projects together. We call that the scrum. That comes from Agile methodology terminology. This is where, just like in rugby, where the 2 teams lock shoulders, they're vying for a position, they're fighting for the ball, they're pushing each other around the field. That's what this is like, getting this many people from this many different backgrounds and disciplines to work together to expedite a remediation program. We decided that we need a control room. A control room is analogous to what Agile experts would call, I think, the data repository. This is where all of the data goes into the same place, and everybody, no matter what project they're working on, has access to it in real time. We named it the control room because we're industrial people. And if you've ever been to a plant, you know that there's a control room there. Why? Because all of the processes have to be maintained in real time. Everybody has to know what's going on in that industrial plant for many practical reasons, but most of all, so people don't die. Industrial plants are hazardous places. So when I was a junior consultant and I had to go and get my excavation permit signed by the client for my daily work permit, usually I was in the control room at 6:30 watching how they operated, all the banks of monitors, all the direct data readouts that the production engineers were monitoring. So we decided, why not use this same concept? And I have to thank Alini and Hui, if you're out there. Guys, thank you so much for sending this over. I didn't have time to look at it, before I put it into this presentation. So I'm going to try to explain it to everyone. So folks, this is what an old school industrial plant control room dashboard looks like. And I'm going to try to explain it. This would not be for the projects that we just talked about. This would be the dashboard for maintaining the source isolation. I'm going to try to explain that to you, though I haven't looked at this yet. So fast forward, when we're post construction, when we're into operation and maintenance mode of this remedy, source isolation using siphons. Why is it important to think about this now? Remember, we're not pumping. We'll have backup pumping if we need it, but the idea is that we use nature, and nature is finicky. We'll have daily pressure variations. We'll have barometric changes. We'll have rain events. We'll have, over the course of time, dropping or rising groundwater levels as climate change continues. We might have sea encroachment. This site is near the coast. We've got to have real-time, 24/7 operation of this isolation system. If we don't, we lose isolation. What does that mean? Water comes in, becomes contaminated, or contaminated water from inside the isolation starts to leak out. So just imagine that you're the remediation engineer who is looking at this dashboard. Your main objective is not losing control of the isolation. So what Hui and Aini have done here is they've drawn all the extraction wells on the up gradient side of the isolation. That's what EW stands for. Remember, we would be siphoning. So this water is coming up under negative pressure. Because of the variability in this project, or this process, excuse me, we need a hold-up tank. That's right here. We call that a kaizen. We put the water from the upstream side into this tank. So this is all the clean water that we've intercepted. We pass into the center of the isolation. And from there, we put it back into a trunk line and pass it back through the manifold on the downstream side. So we're intercepting water, we're transversing across the site with that water, we're putting it back into siphon wells where it percolates, infiltrates, and goes on its merry way. So they've done a great job here. I see the flows, the volumes, everything's measured out in yellow, but what are these red numbers here? Well, I think this means these wells have failed today. You can see there's zero flow coming. So we can have leakage out of the isolation where EW2 and EW3 are. That's what this light is telling you. We got green lights everywhere else, but what happens? The remediation team gets a message in Slack or Airtable or one of these other agile messaging systems. And in fact, the people in charge of this project will probably have this dashboard on their watch or their phone and will check it anytime and can also receive notifications that way. You call the site, we got a problem in these wells, we need to fix this immediately to get the isolation reestablished. So this is a huge learning for me. This is something we've never done before. If we follow Agile, the spirit of Agile, not only are we communicating, not only are we sharing all the information, all the data now through the development process, we're doing that through construction, we're doing it through M&A until we close this site down, until we're done. So closing on Agile, these are our learnings, everyone. You can find all kinds of things online about Agile, but this is what this team has learned over the last 9 months, trying to figure out how we're going to plan this project. First of all, the sprint. Boy, we're tired. 8 months trying to figure this out. We've done very little field work, very little lab work, but putting this all together, remember, it's a huge amount of effort to get this front end loaded instead of just doing the linear waterfall, methodical, slow, time-consuming process. We're just not used to this. The Scrum is conflictive. We're putting people together who are not used to talking to each other. We're putting field people, lab people, design engineers, site folks, and forcing everybody to link together with different backgrounds and cultures and views and come to agreement on how we're going to do this. The variables. You can't be stovepiped. If you're forced to discuss the data needs and the communication needs and the variables that you're going to be needing and that you're going to be generating, that's a conversation that removes all of the insular nature of the standard remediation work streams. And finally, the control room. We're going to learn so much from the production engineers as remediation specialists. They've been doing this for years. We have a sense that when we take this project forward, there will be no more stovepiping, that we're going to do this as an integrated team where all activities are transparent. So we think this has great applicability to sustainable remediation globally, to the problem of global contaminated lands. More than 7 billion people in the world today don't have access to clean water, clean air, clean soil. And we think that Agile methodology can be brought to bear to help remediate global contaminated lands more quickly. There's no better case study than China. China is a huge, challenging remediation market. It is one of the only countries we know of that set up strategic goals on a very short timeline. They have water 10, they have soil 10, and we're a little short on time. I can't go through everything that you'll see here. I appreciate Hannah's efforts. Hannah is interning with us this semester, and she did a great job researching this China case study. Here's where they stand now after approximately 6 years in China. And anyone who knows the Chinese case understands that the problem of contaminated lands in China dwarfs anything that we have left in North America and Europe. This is a truly monumental challenge, and they've made all of this great progress that you see here. But reflecting on what we've talked about today with Agile, with the China case, and with other emerging markets that have all to do when it comes to contaminated lands and have less time to do it than we enjoyed in North America and Europe, we have to acknowledge that this process has got to be more agile. We've got to deal with these remediation projects with full recognition that these emerging markets have to be resilient. There's some opportunities here to partner with established remediation markets to use the spirit and the learnings of Agile. So I really appreciate your time and attention. I know that was a lot to take in, but we want to end with one more poll question, which you'll see here. This is a select all that apply. What are your thoughts about Agile? Nice idea, but probably won't work. Regulators will never buy in. I'm intrigued. How can I learn more? Any potential improvement is worth consideration. Not sure. Thanks again, everyone, for answering this question. By prior agreement, I'm going to pass this over to you, Amy and Chris, for discussion. I think we've got just about 10 more minutes. Really appreciate your time and patience today. Thank you.
All right, we'll wrap up our voting on the poll question in just a second. I'll go ahead and close it out, and then I'll let you know, I'll share our results and then turn it over to Chris.
Great, thanks, Amy. Yeah, great presentation, James. Appreciate the time here. Yeah, so just a reminder to all those, we've had a few questions come in, but if you'd like to ask some more, just go ahead and enter them in the questions box here on the panel. But yeah, we'll get going with our first question here, James. How do you think the public's acceptance or why do you think the public's acceptance to bioremediation is more hesitant in Brazil than it is in the United States?
Thanks for the question. Quick correction. It was my management that was hesitant. It wasn't the regulators. It wasn't the public. People love the idea, especially in Brazil. It was a hesitancy and a lack of tolerance of risk. It was perceived as risky by management. And lots of big companies have the same reaction. Why don't you just go in and install a big pump and treat system and dry up this aquifer? So we know nothing gets into the river. And that's unfortunate. I think we've overcome those preconceived notions of what's good, what's bad, what's right, what's wrong. And now most big companies like mine want to find a sustainable remedy.
Yeah, thanks, James. So next question here, doesn't the Agile work process require that the client remain with the same consultant for the lifetime of the project? How does Agile deal with change in ownership, change in stakeholders, change in consultants, etc.?
Wow, what a great question. And I haven't thought about that. I guess I should. I am the client. I would like to say, everyone, that the team that you saw on the front slide represents probably 8, 10 different companies. Our process of resourcing our needs is focused on people. This is part of our social sustainability goals. So we're a real mishmash of companies, obviously, but when people change companies, we stay with those people. I'd have to think about the more standard approach where you would be changing periodically the providers that you use. Could I take some time to get back to you, Chris, and then maybe you could forward on a more concerted answer than what I just gave? Because that's a great question.
Yeah, absolutely. We'll make note of the asker, and we can maybe even post that question as part of our YouTube channel there. I'll look into that. We've not done that, but I bet we can accomplish that. So yeah. So moving on here to our next one. Does Agile emphasize the critical path, which means any item along the path gets delayed, the whole project gets delayed because of the variable sharings?
No, that's counter to Agile. I'll give you an example. We're behind because of COVID. I'm participating in that tank test that I was talking about. We started the tank test. Half of the 16 input variables that we need from the field investigation are physical. Normally, the critical path would be, well, hold off on building your tank test, right? Because those physical parameters are mainly about soil and flow rate. But no, why don't we just guess and accept the risk, accept the uncertainty, and put the dirt in the tank and start now. And then when the people who need to fly to Brazil finally have authority to do that and approval by the Brazilian government, they start digging holes and sending us data through the control room. And if we made mistakes in our assumptions in getting this started, we need to do over. But let's get going right now. There is no critical path. That might seem to be a fairly glib answer, but it's a great question. That's what you have to get around. And immediately, as we started this project, we began to see how we can't follow that standard approach any longer. I hope I answered the question. I'm not sure I did.
No, I think that's a great answer and a great, discussion on the risk acceptance and maybe some give and take and trust between stakeholders to continue moving forward and address a new problem as it comes up. And yeah. Next question here. What has been the regulatory agency response? Are you bringing them in? Is it well received? Are they part of that process, et cetera?
We have not talked to any regulators yet. And Chris, I didn't get answers or see answers on the poll. That was one of the important points of feedback that we wanted. The second option there, regulators will never buy in. So everyone, my company, we choose benchmark sites where we try new things and innovate every few years. This is one of those sites. And I don't think we've tried anything this innovative in a long time. Our approach, if we think that something is right, and remember that outside of Europe and North America, the regulatory regime is much more flexible, much more sustainable. They embrace new processes much more readily because they don't have this straitjacket of regulatory rules and procedures that have developed over the last 40 years. That said, I have every confidence that when we sit down and talk about what gains we're going to have, our regulators in this part of Brazil are going to say yes. But we wanted to ground truth this with your experiences, no matter where you are. That's why this was part of the last question that we asked. Do you think this is going to be a problem? If you wanted to use this in your jurisdiction for you to get regulatory approval, that's what generated that choice in the last question that we asked, Chris.
Yeah, just so an update for you, James, there, looking at the poll response here, we did have about 10% of our audience felt that regulators will never buy in. About okay. 40% were intrigued. 73%, said any potential improvement is worth considering.
Okay, thank you very much. That's heartening. Appreciate that.
Yeah. So next question here, do you think Agile will save overall project costs? With that, do you believe it will reduce mobilization, on-site efforts, et cetera, which will reduce overall project footprint, greenhouse gas emissions, et cetera?
Let's talk about cost first, but this should never be the primary consideration. Primary consideration should be sustainability and resilience. The case study from Brazil was 37 million reais. Over time, that exchange rate, Brazilian real to dollar, has changed. We're still not done. I'm not sure what my reserve is for this new site is, but it's well shy of that to get us through the end. Well shy of that. If we save time, we will always save money. But by the same token, if we save time, we're always going to be more sustainable. We're going to expend less energy. We're going to generate less emissions. We're going to have lower environmental footprint. We're going to be safer. It's less man hours in the field, less risk to everyone involved. So my answer to this would be a resounding Agile could generate savings across every factor that you would want to consider in evaluating efficiency in the remediation process.
Yeah, no, I appreciate it. I think at that point, that's about all we have. That's all we have for questions here. So with that, I think we'll move on to our next slides. Just touch on a few things here for SURF. So you can go ahead and advance that. Yeah, so just a quick reminder to everybody, for more information related to SURF, make sure you check out our website, sustainableremediation.org. Also these, as well as past webinars, want to make sure we touch on our site-wide and CIFA how-to videos, as well as our recent SURF meetings. We're getting all that on the YouTube channel, so go ahead and make sure you check that out. Make sure you subscribe to our emails listserv. Make sure you don't miss any of these future webinars. And then also just make a note of the 7th International SUSTREM Conference in 2022 coming up in March as part of collaboration with the AEHS West Conference. And then with that, we'd just like to leave with a final thank you to our sponsors. Again, James, thanks for presenting, and we'll conclude with that, and hope to see you all in the next presentation. Thank you.